In this video, we're going to have a look at trig graphs, specifically the sine, the cos, and the tan graph. And what you'll notice is that it's almost like we had our Cartesian plane with the 4 quadrants like this, but what we've done now, we've gone 0 to 90, 90 to 180, to 270, to 360, and what we've done now is we've almost unfolded it into a graph form. Okay, and so we can draw a graph y in terms of the x-axis. There is going to be a theta axis for this graph, and at grade 10 level we are generally asked to draw from 0 to 360, so just one revolution of the Cartesian plane. Okay, when it comes to doing this, we can draw using a table method, so basically plotting point by point. And for sine and cos, you're going to see that you are quite safe if you can plot all of these points. Okay, and if you're nervous that you're going to forget these degree values here, try and think back to the Cartesian plane and try and picture this as an unfolded cast rule, if you will. Okay, so what we've got here is the axis is set out and ready. They don't always give this to us, so we need to be ready to draw it. And if we are asked to draw it, we need to make sure that we have equal increments here. So every 90 degrees, in this case, you can see is 2 blocks. And here I've marked out 1, 2 would be up there, minus 1, minus 2 would be all the way down there. Okay, so nice and neat and accurate. If they don't give us a grid, we use our ruler. Okay, and now we're ready to plot. Okay, and I think it's safe to say for sine and cos, if you plot 0, 90, 180, 270, and 360, you are going to be great. Okay, so you can draw this in a table method. I'm going to just pop the calculations here underneath each other. So sine of 0 degrees, sine of 90, 180, 270, and 360. Okay, so on the calculator, we can literally type those in, and they will give us a value for each of them. Right, and you can check me on that. So sine of 0 gives us a y value of 0. Sine of 90 degrees gives us a 1. Sine of 180 is 0. Sine of 270 is minus 1. Sine of 360 is 0. And so here we have what is known as a sine wave. And it is good practice to label your graph. So y equals sine theta. And then to label any intercepts that aren't already labeled. So that one is labeled, 180 is labeled, 360 is labeled. And any turning points. Okay, so this is 90 degrees and 1. And this is 270 degrees and minus 1. Okay, so it is very possible to draw this using your calculator like we've just done, but I encourage you to remember this. Okay, remember these points. So for me, I can picture this graph because I've drawn it so many times and I know what happens at 0, what happens at 90, etc. Okay, the other thing I like to remember is that the sine graph starts at the center. So S for sine, and although it's not spelled the same, C for center, that's a nice sounding way to remember it. So sine graph starts at the center. All right, this is what we call the parent graph of sine, and we are going to adapt it, but we'll wait until our next video for that. Let's draw the cos graph and the tan graph first. Okay, so for the cos graph, we're going to do the same thing. We're going to say cos of 0, cos of 90, 180, 270, and 360. Okay, and we're going to work each of those out on the calculator. All right, we're not always going to rely on our calculator. We are going to get to a point where we know these off by heart, but for now it's okay. So if you type in on your calculator, check that it's in degree mode. Cos of 0, you should get 1, etc., etc. And then what we do is we accurately plot those points. Okay, so this is here a theta axis. Okay, they could also ask us to draw the graph y equals cos x, and then that would be an x-axis, or cos beta, and that would be a beta axis. Okay, it's important. This little bit of information here I find stresses a lot of people out, and it doesn't need to. All that they're saying is that we need to draw from 0 degrees up to 360 degrees. Okay, and as you move on through your high school career, they could stretch this out or squash it or whatever. and we could draw for different sections of the domain, whatever they tell us. Okay, so don't let this throw you. They've asked us to draw a cos graph, and we know how to do that. Okay, so point by point, cos of 0 on the calculator gives me 1, cos of 90, cos of 180, 270, and 360. So there we have it. This is going to be the parent graph of the cos function, okay, because there's just everything is just 1 here. And I'll start to show you in our next video what happens when we transform this graph. Okay, so there's a cos graph. So this y is equal to cos of theta. And we want to label the turning point. It turns at 180 and minus 1. And then here's an endpoint that's just hovering. It's not on any axis. So let's label that 360 and 1. Okay, it's always sad for me when people lose marks unnecessarily because they didn't label all their points. Okay, so then we have the parent graph of the cos graph. It's got a very similar shape, actually, to the sine graph, but sine started at the center and then went up and down. Cos starts at 1 and then moves down and then up. Okay, now for the graph of tan theta. So let's have a look at that. So we're going to want tan, and then we're going to take all of our points. 0, 90, 180, 270, and 360. Okay, pop those into your calculator and let's see what we get. Tan of 0 gives us an answer of 0. Tan of 90 gives us an error. 180 gives us a 0. 270 gives us an error. And then 360 gives us a 0. Okay, so this is tricky to draw with the information that we've been given here. I've got a 0 here. I've got a 0 here. And a 0 here. Okay, so this is not enough information to draw the graph, but it's also not a reason to panic. Okay, so if you are given this tan graph and they want you to draw it, I want you to remember that you can plot more points. Okay, so let's add some points in between. If you have a look at your axis, between 90 and 0, there's another point here. There's a 45-degree point there. So we can definitely work that out. Okay, and then here is a 135 degree. Here is a 225. And here is a 315. Okay, so I've just added in between every 45 degrees another point. Okay, and so let's work out those, and then we'll see if we've got any cause for concern. So tan of 45 on the calculator gives us an answer of 1. Okay, so now we're looking good, back on track. Tan of 135 on the calculator, that'll give us an answer of minus 1. Minus 1 over there. Tan 225 gives us an answer of 1. So that's up there. Tan 315 gives us an answer of minus 1. All right, so we definitely have more to go on now. And we may be tempted to go, well, let's join this thing. All right, but we're not allowed to do that. We need to pay attention to the fact that our calculator gave us an error, because that's actually important. All right, what happens when the calculator gives us an error and we are drawing graphs? It means we have encountered what is called an asymptote. Now, we've seen asymptote before with our algebraic graphs. So basically, a graph that the graph approaches this line, but it never touches and it never crosses. Okay, so those asymptotes we then need to draw, and we need to label them. So this is the line here where theta is equal to 90 and where theta is equal to 270. Okay, so now to draw this function, we just need to be quite alert, but that's okay. Once we understand the shape, it's also not too bad to draw it. Okay, so in this quadrant here, I've got 0 and 1. So I can join those, okay, and it's going to go on forever in that direction, but it can never cross over that 90-degree line. Okay, in this quadrant here, we've got a minus 1, a 0, and a 1, and so this tan graph is going to take on a bit of a shape like this. All right, so it's going to move down towards the asymptote again and then up towards the asymptote, or technically in a wave fashion. Okay, and then finally we've got one more arm here in the last quadrant, and there we go. Okay, so this is how we draw the tan graph. Very important that you can't just draw it on the 90 and 270, or with these basic points 90, 180, 270, 360, because you'll end up with zeros and errors. The other thing to remember is if you are given an error, it simply means it's an asymptote. So draw those in, label them. Okay, and then we generally want to label this graph. Y is equal to tan theta. And normally what we do is we label any intercepts and endpoints and turning points. Okay, but here we don't have too much to go on. And so it's become a habit to label this point here at 45 degrees and 1. Okay, and if you think back to your special angles, tan of 45 does equal 1. So everything is connected. 45, the tan graph is equal to positive 1. Okay, there are a couple of things that we need to know about these sine, cos, and tan graphs. So let's spend a few minutes looking at that. So here we've got the parent graph of the sine function. I'm going to color code these so we can make sense of our answers. The cos graph, there we go, and finally the tan graph with its asymptotes, not a problem, there we go. Okay, these parent graphs, like I said earlier, go and learn them. Learn these points, 0, 1, 0, minus 1, 0, or simply that sine starts at the center, cos starts at 1, and tan has these asymptotes, and then 45 and 1 is important. Okay. We could be asked any range of information or questions on these graphs. Okay, so if they say to us what is the domain, that's the x values for which this graph can be defined. Okay, now at grade 10 level we are restricted to a smallish domain. Sometimes our teachers stretch us a bit and they might ask us to draw beyond, but it's important to know, grade 10s, that this graph can carry on in the negative direction and it can carry on again because trigonometry works on that cyclic concept. Okay, but for this graph here, the sine graph, we were simply told that x is an element from 0 up to 360, and it's defined at all of those points. So I'm going to use square brackets there. Okay. The cos graph is the same thing. X is an element from 0 to 360. Everything is defined. Okay, but the tan graph, because we hit some asymptotes, we just need to be on our guard there. X is an element from 0 to 360, but x is not allowed to equal 90 or 270. Okay, so the asymptotes there need to be excluded from that domain. Then the range, let's have a look. So the range here, we want to go from smallest, minus 1 is my lowest point, 1 is the highest point there. So y is an element from minus 1 up to 1. And then here, my lowest point in the cos graph is minus 1, highest point is 1. Okay, that's going to change when we start transforming these. But for this particular parent graph, that's 100% true. And then in the tan, y is an element. This is pointing down. These are my minimums, down to infinity. And those maximums are pointing up to infinity. So y is an element from minus infinity up to infinity. Okay, and infinity always gets round brackets. All right, now period, that's a new word for us. That's the time it takes for one full wave to complete itself. Okay, so basically if I followed the sine graph, it would go, and by the time we got there, 360, it would be heading in exactly the same way it was when we were at 0, so then it would go up again. So the period of a sine graph is 360 degrees. A cos graph also takes 360 degrees to complete, and a tan graph is a little bit different. Okay, I always find it easiest to look here in the middle section because this is one full wave. So between 90 and 270, that's 180 degrees. But you can look at it, let's quickly write that down. You can look at it here. So one arm going up and one arm going down. That is completed there at 180. And then the graph starts to repeat past 180. It's a duplicate of what happened here. Okay, so the period of a tan function is 180 degrees. Okay, amplitude is an interesting theory. Okay, amplitude is basically your maximum minus your minimum divided by 2. That's how you can work it out. Okay, it's the distance between the highest point and a point of rest, or the lowest point and a point of rest. Okay, so you don't always have to calculate it. You can actually just look at your graph and see. So between this point of rest and 1, there's 1 unit there. So the amplitude here of this graph is just 1. Okay, or if I wanted to, I could have said 1 minus 1, so that becomes 2 divided by 2, which gives me an amplitude of 1 there. All right, the cos graph has the same amplitude there. The distance between rest and the highest point, the maximum point, is 1 unit. The tan graph is a little bit different, okay, because here's its rest point, but it goes on forever. Tan graph doesn't have a maximum. We can't define it. And it doesn't have a minimum. We can't define it. So tan graph has no amplitude. All right, and then the asymptotes. There are no asymptotes in a sine graph, no asymptotes in a cos graph, but a tan graph has got 2, and those are at x in this case. I see the x graphs. So x is equal to 90, and x is equal to 270.